Hello everyone, I am Babruvan Solunke, Assistant Professor, Department of Computer Science and Engineering, Walchand Institute of Technology, Solapur. Today I am going to teach the concept of reduced parsing in compiler construction. Learning objective: by the end of this session, students will be able to understand the concept of reduced parsing in compiler construction with its working principles, operations and applications. So start with working principles. Reduced parsing is a bottom-up parsing techniques that builds a parse tree by shifting the input symbol onto the stack and reducing them using the grammar rules until the start symbol is derived. There are 4 operations which can be performed during the shift reduced parsing. So start with shift. Shift means push the next input symbol onto the stack. Reduce, replacing the sequence of symbols appearing on the top side of the stack with a non-terminal symbol using the grammar rule. Except if the stack contains only the start symbol on the top and input is fully parsed, then we are going to accept the given input string as a valid. Otherwise, we reject that input if no valid reduction or shift is possible. The general idea is in this parsing is shifting the symbols appearing in the input while scanning from left to right onto the stack until the reducible string can be appear on the top of the stack, so that we can perform the reduction operation. And at each reduction step, a specific substring matching the body of a production in the given grammar is replaced by the non-terminal at the head of the production. The key decisions during the bottom-up parsing are about when to reduce and about what production to apply at each step to derive the given input string. A reduction is a reverse of a step in derivation. And the goal of bottom-up parsing is to construct the derivation in reverse order. So shift reduced parsing is a bottom-up parsing techniques. Therefore, it is also called as producing the rightmost derivation in reverse order. Okay, so here we have one small example of how to produce the rightmost derivation in reverse order for the given input string using this following grammar E with heads E, T and F. Input is ID star ID. So in this input, the string ID is matching the second production of F. So this string ID can be reduced to F. And in the second step, in the reverse order, this F matches the second production body of T. So F is reduced to capital T. In the next step, this second ID is reduced to F. Now this string is T star F in this step. So T star F matching the first production of T. So T star F can be reduced to the head of the production capital T. And this capital T is a body of the second production of E, which is reduced to capital E, and E is the start symbol of the grammar. So when we reaches to the start symbol by reducing the given input string, then we can say that the given input string is parsed successfully and it can be accepted. And in the shift reduced parsing, we have the concept of the handle pruning. Pruning means reducing the given string appearing on the top side of the stack. And here the handle means a substring that matches the body of a production and whose reduction represent one step along the reverse of a rightmost derivation. Here we have 3 columns. First column have the right sentential forms. Right sentential forms are the string appear in each step of the rightmost derivation in reverse order. Second column contain the handles of the right sentential form, which are matching the production body of the appropriate productions. So which is given in the third column. The handles are reducing by using which production. So initially ID star ID is the given right sentential form. So here the ID, first ID in the left to scan right is matching the second production of F. So ID can be reduced to the head of the production F. So in the next step, this F is again matching the production body of T. So F is reduced to T. Then ID is the next handle, so it can be reduced to F. Now T star F is the string, and this T star F matches the production body of capital T, and the capital T can be used for replacing this T star F. And finally this capital T is reduced to capital E. So as I have already said that stack is a data structure usually in the shift reduced parsing for holding the grammatical symbols during the SIP-reduce parsing, and these handles are always appear on the top of the stack. So, in the initial configuration of the SIP-reduce parsing process, the stack is empty, which is having the dollar symbol indicating the bottom of the empty stack, and the input consists of the string W followed by the end marker dollar. And after applying all the operations appropriately in the SIP-reduce parsing, the accepting configuration of this parsing technique consists of the stack containing the start symbol on the top, and the input is completely exhausted, indicating only the end marker. So, here we have one example of the SIP-reduce parsing process with these basic operations: SIP-reduce, accept, or error for the given input ID star ID. So, we can see this process in 3 columns. Stack column indicate the status of the stack containing the appropriate grammar symbols. Second column is the input symbols, and third is the what kind of the action or operation to be performed during this parsing. So, initially stack is empty and the given input is having the first symbol ID. So, if the stack is empty, then always perform the shift operation onto the stack. So, we shift this ID symbol onto the stack on top side, and this ID is a string matching the second production of F. So, we can reduce this ID to capital F in this step, and in the next step F is again matching the production body of T. So, F is reduces to T, and if T is there on the top of the stack and next symbol is star instead of plus, then we shift this star onto the stack because star has higher precedence than this T. So, T star is not reducible, therefore, again we need to shift the next input symbol, shift ID as the next input symbol, T star ID is the string, and here ID is matching with the production body of F. So, ID can be reduced to capital F. Now, the string appear on the topmost side of the stack is T star F, which is also a handle matching the production body of this T. So, T gives T star F. So, therefore, T star F can be reduced to capital T in the next step, and this T can be reduced to capital E by using the E gives T production, and after that the input is already exhausted and the symbol on the top of the stack is only the start symbol capital E. Therefore, we have reached the accepting configuration. Therefore, given string ID star ID is a valid string. Take a pause, you think and give the answer. Which data structure is used in SIP-reduce parsing? Queue, stack, heap, linked list. Here the correct answer is B. Stack is a data structure used in SIP-reduce parsing. Now, the real world applications of SIP-reduce parsing. In compiler and interpreters like GCC, Clang, Java CC, we can use the concept of the SIP-reduce parsing for syntax analysis and translation. In the natural language processing, the chatbot, grammar checkers, machine translations can use the concepts. Database query processing techniques, here parsing the SQL query in database system for execution or optimization. For this parsing of the SQL query, we can use technique of the SIP-reduce parsing. XML JSON parser also uses the concept of SIP-reduce parser for processing the structured data in web application, browsers and APIs. Code auto completion in the integrated development environments, which help in syntax aware code suggestions in the IDEs like VS Code, IntelliJ and Eclipse. So, these are the real world applications of the SIP-reduce parsing. These are the references for preparing the PPTs, compiler principal techniques and tools by Alfred V. Aho, Monica, and second is getwiththat.com, having the concept of SIP-reduce parsing. Thank you.